Our next topic is solving absolute value inequalities. If you think back, the absolute value of 3 means that the distance between x and 0 is 3. X could be negative 3 or positive 3. When we're talking about an inequality here, the absolute value of x is less than 3 means that the distance between 0 and x is less than 3. So if we have 0 in the middle, we're looking at anything where the distance between that number and 0 is less than 3 spaces away. If it was an equation, it would just be those 2 points, but it's everything that's in between. Anything on this green line is less than 3 spaces away from 0. So this would be also written as an and inequality, that x is between negative 3 and positive 3. Negative 3 is less than x is less than 3. The inequality of absolute value of x is greater than 3 means that the distance between x and 0 is greater than 3. So with 0 in the middle, and 3 here and negative 3 there, the distance between anything I'm going to plot and 0 has to be more than 3. So it can't be 3, but it has to be more than 3 away. So it can't be at negative 3 because that's 3 away from 0, but it could be more than 3 away. It could be that way. So the absolute value of x is greater than 3 is really an or inequality. X is less than negative 3 or x is greater than positive 3. So when you have the absolute value of some expression is less than a positive value, it becomes a compound inequality, an and. So less than c becomes an and, where that expression inside the absolute value is between the positive and the negative versions of that number. When an expression in absolute value is greater than c, you have an or. In this first example, you're going to have an or, because you have something is more than or equal to 7 spaces away. So I have x minus 5 is greater than or equal to 7, or x minus 5 is less than or equal to negative 7. You might want to switch that. Oops, the or came with it, sorry. So I'm solving two inequalities. I'm adding 5 to both sides for both of them. X is less than or equal to negative 2, or x is greater than or equal to 12. So on my number line, I like to pick 3 numbers, negative 2 and 12, which technically would make this 5 be in the middle. So it's less than or equal to, so it's got a closed circle, and it's got an arrow to the left. Here you have a greater than or equal to on 12, so you have an arrow to the right, and again, a closed circle. In the next example, you have to do a little bit of something else. In the example 2, you need to get the absolute value expression by itself before you figure out whether it's going to become an or compound inequality or an and. If I have the absolute value of negative 4x minus 5 plus 3 is less than 9, my first step would be to subtract 3. Once I have the absolute value of negative 4x minus 5 is less than 9, the distance between this expression and 0 has to be smaller than 9. It's in the middle. It's closer. It could be 1 away, it could be 2 away, 3 away, 4 away. So this becomes an and. In an and inequality, you put the expression in the middle. Negative 4x minus 5 has to be less than 9, but it has to be greater than negative 9. If you're thinking about it, an and inequality always gives you a segment. So now I have a compound inequality to solve where I can add 5 to all the parts. and I get negative 4 is less than negative 4x, which is less than 14. And then I'm going to divide everything by negative 4. Because I'm dividing by a negative, I have to switch the signs. So I get 1 is greater than x, which is greater than negative 14 over 4 is negative 7 halves. So if I rewrite it, negative 3.5 is less than x, which is less than 1. That would be a nice answer. So on my number line, I have my numbers that I'm really worried about here, negative 3.5 and 1. It's not equal to them, but it's in between them. So I have a segment with no endpoints. This is not about absolute value inequalities specifically, but any inequality can have a solution written as an interval instead of with x and a greater than. It can represent the solution as a pair of numbers. The numbers are the endpoints of the interval. Parentheses or brackets are used to show whether the endpoints are included or excluded. Excluded is like less than or greater than. Included is less than or equal to, greater than or equal to. So the table below shows the relationship between inequality notation and interval notation. You put 5 on the left, you put parentheses and infinity on the right. If it's equal to, you get a square bracket. If it's less than, you put negative infinity on the left, and you still use parentheses. You never use a square bracket with infinity or negative infinity because that's not a number. When you have a compound inequality, you have a number between 2 points but not equal to is going to look like an ordered pair. It's going to have parentheses and the 2 numbers. If it's got an equal to on one side, it's going to have bracket. If it's an or inequality, because that's 2 separate inequalities, you write them just like the first couple examples, but in the middle you put this u. This means the union. It means both these things are true.